Hello, in this video I'm going to solve question 2, Problems Set 3, Lecture 4, Lectures in Elementary Number Theory. Let a, x, y, and z be integers such that x squared y divides z and z divides x plus a. Show that x also divides a plus z. Pause the video at this point and give it a try. Okay, so let us solve this problem. As I always mention, for these problems, the solution that I present here is by no means the only way. I'm just following my own lectures, so these problems are designed based on the lectures on the same playlist that you see elementary number theory. So I am trying to use the theorems that I have presented in my lectures. Okay, so I will not start from scratch. I want you to be skillful in using those theorems. But that's a very simple problem. So here we know that x squared y divides z, and I know that z divides x plus a. I want to prove that x also divides a plus z. The method that I want to use here, I want to prove that x individually divides a and z, and then we had a theorem in the previous lecture on this playlist that if a number divides two different numbers, it divides any linear combination of those numbers, including the sum of those numbers. So from here, you know that x squared y divides z. So from here, I can conclude that x squared divides z. I can conclude that y divides z based on the theorem that we had before. So here, for example, I can consider that x squared divides z. And again, x squared is x times x. If z is divisible by x squared, it is clearly divisible by x itself. So I can conclude that x divides z. Okay, but now from here and here, I have the transitivity. If I know that x divides z, and according to the problem, z itself divides x plus a, based on transitivity property of divisibility, I can conclude that x also divides x plus a. Okay, and then if you remember in one of the lectures, we had this theorem that if I have a divisibility relation, I can add any integer multiple of the left-hand side to the right-hand side. The new divisibility relation is also true. So here my goal is to eliminate this x. So I will add minus 1 times of the left-hand side to the right-hand side. In other words, I can conclude that x divides x plus a plus minus 1 times the left-hand side. But minus 1 times x is minus x, and x are cancelled, so I can conclude that x divides a. Okay, so here I have x divides z, and now I know that x also divides a. That was a theorem in the previous lecture. If two numbers are divisible by the same number, any linear combination of these numbers, including the sum of those numbers, is also divisible by that number. So from here, based on that theorem, I can conclude that x divides the sum of these two numbers. X divides z plus a or a plus z, which is the same. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.